My name is Spradlin. My team members are Kevin McAlister and Sean Armstrong. We're here to discuss the Knoxville interstate traffic for CE 551 traffic characteristics. Our project objectives are to discuss the two conditions of historic and the day before Thanksgiving. With these conditions, we will be discussing the following topics: fundamental relations, lane distributions, and travel time. The data we received was from TDOT Region 1 Traffic Office, and the data was for each lane, the speed and volume of traffic. From now on, we will consider condition 1 as historic and condition 2 as the day before Thanksgiving. Lane 1 will be the outermost lane or rightmost lane. The following locations were used in our analysis. I-40 at Gallagher View Road will be now defined as point A, which is west of Knoxville. And I-640, I-75 north of I-40 will be now defined as point B. I-640 at Millertown Pike will be defined as point C. And finally, I-40 at Asheville Highway defined as point D. Now I'd like to hand it off to Kevin McAlister to talk about the fundamental relations.
Thanks, Connor. My name is Kevin McAlister, and I want to talk about our data. We got our data from Region 1 TDOT personnel, like Connor said, and we wanted to compare it at two different points in time. Once was an average day. Condition 1 was an average day. Condition 2 was the Wednesday of Thanksgiving weekend. We wanted to take that data and compare it to the fundamental relationships that we learned in Dr. Hahn's class with the speed, flow, and density. And these were the curves Dr. Hahn showed us in class, and we want to see if real traffic data compares to what we learned in class, and if we get these nice curves out of real data. So let's see what we found. We were expecting a lot of traffic on the weekend of Thanksgiving through Knoxville. So what happens when you get a lot of traffic? Speed slows down, you get gridlock, and traffic doesn't flow the way it normally does. So we were expecting to find that in our data. So let's see what we found. So we looked at points A through D over here, eastbound and westbound movements. Condition 1 was an average day, and condition 2 was Thanksgiving weekend. And in this column, we're looking at the percentage increase or decrease of speed. And so across the board, we're getting an increase in speed when we were expecting a decrease. Oops, let me go back. And so I've highlighted this box in yellow because we had a decrease in speed at two locations, this one being the most. Let's look at the flow. So we had a consistent increase in flow, vehicles per hour across the board, so that matched our expectations. With the maximum being here at point B, westbound movement, that was at 640 I-75. And here in density, we had another consistent increase across the board, which again matched our expectations, with the maximum being here at point D eastbound with a 55% increase in density at I-40 at Asheville Highway on the east side of town. All right, so let's explore. I want to talk about that point in particular, I-40 at Asheville Highway on eastbound in particular. Let's look at those curves and see what we find. So this is the data from that particular station, the red points being an average day and the blue being Thanksgiving weekend. The trend line is matching what we found in class. It's beginning to peak here and turn downward, and that's going to match our our flow density curve over here. Now let's compare speed and density. That's this curve here, and we're matching what we find in class. We're getting a downward trend, the red and the blue. And the same with speed and flow. We're comparing to this curve, and we're matching the shape with our scatter plot here. That was the one point that met our expectations the most. So what else did we find? That only one point matched up with the classroom fundamentals, and we were trying to figure out why that was. We think it's because all the other points on the interstate had the capacity for the additional traffic volume of the Thanksgiving weekend. So now I'm going to hand it off back to Connor, and he's going to talk about the lane distribution.
Thank you, Kevin. So traffic lane distribution is easily calculated. It's based off of the volume of each lane was then divided by the total volume, and then converted into a percentage. Now, the volumes are added up through all 24 hours, so there is no time of day, peak hour calculation in that. So what we expected to see in there was just evenly dispersed traffic throughout the entire corridor, or for each point. However, that's not exactly what we saw. So one of our immediate outliers is at point A, the eastbound lane 1 is only around 5%. Well, when we looked at this a little bit more in depth, we noticed that lane 1 is actually located in a long weaving segment, which can be attributed to the traffic merging back onto I-40, and the traffic has not yet diverged into the lane 1 where the RDS is actually taking that data. So that can be the 5%, 5 and 6% could be attributed to such low numbers because of that reason. But when we look at lane 2, 3, and 4, you see traffic is fairly evenly distributed, being around 25, 26, 23, and 17% across each lane. Now, when we look at the difference of the conditions, we can see that there's not very much difference. We see that traffic basically behaves the same way on for your historic data and for the day before Thanksgiving. And that can be seen amongst all the other data points. So when we're looking at the westbound at point A, we also see a very even distribution of traffic. When we move on to point B, however, we start getting some discrepancies. We're coming around 28, 26% going into 34% to the next lane, which is a larger difference than what was in point A. But where you really see a big difference is when you look at point B westbound. And we actually have 50% people traveling in the second lane, with only 10% traveling in lane 3. And we kind of thought, well, why is this happening? Well, when we looked at where the RDS is located, it was actually located right here, traveling on I-640 westbound. So right now we're traveling I-64 westbound, and I-40 is running across the screen, west, east. So it doesn't make sense for people traveling on I-640 westbound to actually merge and go to I-40 eastbound. It doesn't make sense in your head. And when we brought the data up, it really shows that most of the traffic is actually going I-40 west or 75 south. So when we look at point C, we actually had some discrepancies in our data, which would prevent us from using a fair analysis between eastbound and westbound conditions. When we're looking at the westbound conditions, you can see that most of the traffic is actually traveling in that middle lane, and the same thing for point D. A lot of the traffic is traveling at the middle lane, being 40% and 50% for point C. When we looked over at point D westbound, we noticed that there were 6 lanes in our data, but when we looked at Google Earth, we actually saw that there was only 4 lanes. So we still measured the data anyway to see what it would show. However, take this with a grain of salt, but it can be seen in this data if we use these 3 lanes and these 3 lanes separately, the middle lane is traveled more, which we have 22% and 20% compared to the 16 and 15 around it. So what we expected to see did not match what we actually saw. Let's review, and we expected to see an even distribution. However, what we saw is really that many drivers travel in the middle lane, and that can be backed up by maybe some driver behavior characteristics, where many drivers use that right lane for a merge and diverge, and many drivers use the left lane as a passing lane. So most drivers are very comfortable just cruising in that middle lane, getting from point A to point B. Speaking of point A to point B, I'd like to hand it off to Sean to talk about the best way to travel. Hey.
Thank you, Connor. I'm Sean Armstrong. We decided to take another look and bring in the element of travel time. The way we approached this was we just wanted to look at the westbound direction, because we did have a discrepancy in the data at the Millertown Pike for eastbound. We reviewed the travel times for both conditions, so the historic and the day before Thanksgiving. And here's the two paths we looked at was I-40, taking it through Knoxville from Asheville Highway to Gallagher View Road. So that's point D to A, which is approximately 14.3 miles. And then we decided to go, well, let's take the loop around and do I-40 using around I-640, going from point D, C, B, and to end at point A at Gallagher View, which is approximately 17 miles. So this is our path, starting in Asheville Highway, point D, coming through Knoxville, ending at point A over here, and then the second path, point D here, going up I-640 around Millertown to Middlebrook, ending at Gallagher View Road to there. So we had to make a few assumptions. First one was we had to average the speed between the two stations. So from point D to point A, those two stations, we averaged the speed, and then we had to assume the speed was constant between those. This here is an overall view of what the data was presenting to us. So you see the heavy bold line here at the 0%. What this is telling us is the closer you get to 0%, you're at a point to where you can almost pick which direction you want to go, and you'll have the exact same travel time based on the assumptions we used. So starting over the left side from midnight, you can see how the two trends between historic and the day before Thanksgiving kind of hold steady, maybe a little exception here at the beginning, but at this time in the night, there's plenty of capacity on interstate to hold whatever traffic's out there. As we start getting towards the middle, specifically here around this lunch hour and out here towards the evening peak, we start seeing where we drop below the 0% line. This is basically telling us that it's faster to take I-640 around Knoxville, the longer distance, than to go I-40 through Knoxville on the day before Thanksgiving. Historically, it's safe to say going through Knoxville is still the fastest way. With a little bit of a dip here around the evening peak, it is saying it's a little faster to go 640 around. And day before Thanksgiving, it really is saying it's faster to go around 640. As a driver, sometimes you get in slow traffic, you may get more of a window here where more drivers may actually still take the longer loop just because they're moving faster. Towards the end of the graph here, we get in the later hours of the evening. You can see we get the capacity is okay. There's not as much traffic on the interstate at that time, so these two trends hold steady. Moving on, we decided to look also at, well, what's the difference in travel times between each leg of this route? So looking at the first leg, going from Nashville Highway to Gallagher View Road, straight through Knoxville, we do see that it is faster during the day before Thanksgiving than it is during the historic. And that kind of holds steady through all of these, with the exception of from Middlebrook to Gallagher View Road, which actually says that, well, historic is faster than the day before Thanksgiving during that leg by a little bit. Well, this correlates back to Kevin's graph, where he presented his speed data and his percent difference, and we see for that at point B, which is at Middlebrook, that speeds dropped from 57 to 56, which correlates to more volume on the interstate, which allows for less speed to happen. So to sum everything up, we had our final thoughts put together. What we realized was that speed, flow, and density curves, only one point really matched up closely what the classroom models presented. Lane distribution acted the same for both conditions, where everybody kind of hovered towards that middle lane. And then for travel time, give a real accurate analysis of these travel times, we would need more RDS stations throughout the corridor for each route we're analyzing, specifically identifying in between every interchange to have that speed data to really get a good idea of that speed time to kind of help remove some of the assumptions we used. I want to thank TDOT for providing the traffic data we've got. I thank the team members, Kevin, Connor, Dr. Allen, thank you as well for the semester we've had. It's been an enjoyment learning all the different things about traffic. And we'll sign off on that. Thank you.